Welcome to the Math Record. Today I'll be covering the ICTM State 2015 Division A Geometry. I'll be going through every single question from 1 to 20 in that order, and if you want to look for a specific question, I'll be linking it in the description. Okay, number 1. Determine the exact perimeter of an isosceles right triangle with a hypotenuse of length 6. So usually for geometry you want to draw a picture, and it says isosceles, so this is x and this is also x, which we denote, and we call this 6, right? So using the Pythagorean theorem, x squared plus x squared equals hypotenuse squared, which is 36. So that means x squared is equal to 18. So x is equal to square root 18, which is 3 squared root 2. So when you find the perimeter, so then that's 3 square root 2 plus 3 square root 2 plus 6. So that's 6 square root 2 plus 6. And that is your answer for number 1. Okay. And forgot to make a layer. Okay, cool. Number 2. Circle O is externally tangent to circle P with respective radii at length 4 and 8. A common tangent line is tangent to circle O at point A and tangent to circle P at point B. Determine the exact length of AB. Okay, so basically what they want us to do is they want us to find the length of the common tangent. So let's just kind of draw a line. Okay, and we need some circles. So let's say something like this big. Then something like right here. Okay, so something like that. Okay, so what they want us to find is these 2 points, right? Tangent, when you find this length. So how do we find it? Well, basically, let's just draw our centers. So this is radius 4, so this is length 4. The bigger circle is radius 8, so this is length 8. Now, if we connect the two centers, what's that length? Well, that's radius 8 and radius 4. So 4 plus 8 is 12, so this is length 12. Okay, so now let's draw a line from here to here, and it's parallel to this line. So basically what we did is that we made a rectangle. So if this is length 4, then this right here is length 4. And since this total length is 8, then this is also 4. And since it's a rectangle, if this is x, then this is x. So what we have here is that this is a rectangle, right? So this is a right angle, so this has to be a right angle. So what we have is we have a right triangle, so we can just use the Pythagorean theorem. So x squared plus 4 squared is equal to hypotenuse squared. So we have a x is equal to, then we just use our calculator, so 12 squared minus 4 squared, and then x is equal to the square root of 128. So that's just 64 times 2, so that's 8 square root 2. So that's our length of x, so that's also our answer, because what we're looking for is x. Okay, number 3. Lines L and M are parallel in the figure shown. Angle K is 50. Okay, let's draw this first before we continue any further. Okay, so angle K is 50, and angle P is 80. And we need to find angle B, so this is x. Okay, so basically we could just extend this line out, and then what you need to know about triangles, basically, is that the two angles are not touching the exterior angle, they add up to that angle, right? So this angle is touching this one, so then we just need to focus on these two. So this angle plus this, so this mystery angle plus this angle of 50 is equal to the 80. So that means this one is 30, right? 30 plus 50 equals 80. So if this angle is 30, since this is an alternate interior, right? These two are alternate interiors, that means x is also 30. So that is your answer for number 3. It's basically just that simple. Okay, number 4. In the diagram shown, line AE and AD are secant segments drawn to the circle. And then let me just draw the picture before they describe any of the lengths. So AB is 5, so this is 5. CE is 4. BD is 3. Find the length of AE. So they want us to find this entire length. So we'll just call this X. Okay, so using inscribed angle lines, basically the total length times the part outside is equal to each other. So 3 plus 5 is 8. The part outside is 5, so 8 times 5. So now this entire length, that's x. Now the parts outside is x minus 4. So 40 equals x squared minus 4x. So 0 equals x squared minus 4x minus 40, right? Move the 40 to the other side. And now we'll use the quadratic formula, which is negative b plus or minus b squared minus 4ac. I square root that and then over 2a. So then we have negative b, so 4. So is it plus or minus? It's usually just going to be the plus. If this is negative, then it's going to be a plus. If this is positive, then it might be a plus or minus. But I'm just going to put a plus here because it's usually the one that makes sense. And then b squared, which is 16, minus 4ac. So 4 times negative 4 times this negative 40 is positive 160. So this is positive 160, right? And this is why we have a plus, because if this was a minus, we subtract something even bigger than 4. So this become negative, which is not possible because x has to be positive. And then we divide by 2a. So a is just 1. So it's just 2. So this is 176. So 4 plus square root 176 over 2. So 176, that is just 16 times 11. So square root of 16 is 4. So this is 4 plus 4 square root 11 over 2. So that is just 2 plus 2 square root 11. And that is your answer for number 4. Oh, number 5. Okay, this is a paragraph. And diagram angle BAC in the diagram, angle BAC is a right triangle. So, okay, so looking at that figure, let's just draw on the side. So, okay, from point A, so from the right triangle, it travels to point D on the hypotenuse of ABC, okay, along AD, which is the altitude. Okay, so they go through this path, and that's the altitude. Okay, when it reaches point D, the ant turns and heads towards AC, okay, and along DE, the altitude to ADC. Okay, so we draw on our altitude. Okay, when it reaches point E, the side of AC, the ant turns and heads towards BC along EF, the altitude. Okay, so basically what it's doing, since we don't have to read the rest of this, um, what it's doing is that it went from this point to this point, which is the altitude, and then from this point to this point, which is another altitude, and it does that like 4 times, basically. So then, what is it asking to look for? When it reaches point G on side AC, it stops. Okay, assume that the ant travels in straight lines and does not retrace its steps. Determine the total length of the ant traveled is AB is 12. So this is 12. And AC is 16. Okay. So we need to find we need to determine the total length. So we need to find this plus this plus this plus this, basically. So first we need to find the hypotenuse of this. So what's this? It's basically a 3, 4, 5 triangle, right? Because 12 times 3 times 4 is 12, 4 times 4 is 16. So 5 times 4 is 20. So it's a 3, 4, 5. Okay. So what we could do to find this length first, right? We would get this one, then this, and then these two, right? So to find that length of altitude, what we have is just the entire area of this triangle, which is 12 times 16 divided by 2, right? Base time, base times height divided by 2 is equal to the hypotenuse, which is 20, times the altitude divided by 2, right? The area has to be the same. So that basically tells us that the height is 12 times 16 divided by 20. So that's 48 over 5. Okay, so 48 over 5. So now we need to get this length. But before we get that, since we're looking at this triangle, right, we need to first get this side length. So using the Pythagorean theorem, 16 squared minus 48 over 5 squared, and then take the square root using our calculator, we get 64 over 5. Okay, so we get that length. So now we could do the same thing again. So base times height divided by 2, or you could just multiply by 1/2, is equal to altitude, which is this altitude. So this is our h. So 16 times h times 1/2. So just both 1/2, so we don't have to really put 1/2 in our calculations. So using our calculator, 48 times 64 divided by 25 divided by 16. Um, 48 times, oh, sorry, 48 equals 192 over 25. Okay, so 192 over 25. So we get these two lengths, right? We can actually basically stop there because to get these two lengths is actually really simple. What you need to recognize is that there's actually similar triangles. So we have a triangle right here, and we have a similar triangle right here, right? They both have 90 degrees. They both have these two angles are the same, right? And they both share this angle. So that's why those two are the same. So basically, since all angles are the same, then it's similar. So what you notice then is that since they're similar, that means this side length, I mean this length has to be proportional to this length, and this length had to be proportional to this length. So that gives us the final two lengths. So how do we get that proportion? Well, how do we get from 100? How do we get to 192 over 25 from 12, right? Because we have this triangle and this triangle, right? So our two side lengths are these two that we could compare. So 192 divided by 25, right? And then we could divide by 12, divided by 12, and that should give us our scaling factor. So 192 divided by 12, so that's 16 over 25. So that is our scaling factor. So we have a 48 over 5 times 16 over 25. It gets us this length, right? So we scale from this length to this side length. And 192 over 25 times 16 over 25 scales this length to this length. So those are our final two lengths. And then we just add to these lengths. So 48 over 5 plus 192 over 25 plus 48 over 5 times 16 over 25 plus 192 over 25 times 16 divided by 25. And you should get an answer of 177,12625. And that is your answer for number 5. It just takes a lot of work, but if you don't have time for it, I recommend not solving this question because it takes a long time to read, and then it also takes a bunch of steps for you to get the answer. Number 6, a certain rectangle has length twice its width. So, okay, so we have a rectangle, and its length is twice its width. So let's say our width is here, so our length is 2w. Determine the exact area of a circle circumscribed around the rectangle with a width of when the width of the rectangle is 8. Okay, so we have a circle. So if it's circumscribing it's outside. So we have a rectangle. So our width is 8, which is what they gave us. So this is 16. So basically what we do is just draw a hypotenuse. So that is this hypotenuse, anything for a rectangle, it's always going to go through half. It's always going to, the diagonal always goes through the center. So basically, since these two lengths are the same, then you could just get the hypotenuse and divide by 2. So 16 squared plus 8 squared, square root, divide by 2. And that should be the radius of the circle to get the area squared and then multiply by pi. So then square root of this is 16 squared plus 8 squared, and then square root of 2 is 4. So you just use your calculator. So 16 squared plus 8 squared divided by 4, you get 80. So 80 times your pi is your area, which is 80 pi. Okay, so that's your answer for 6. Number 7. ABCD is a rhombus with BAD is equal to 60, so degrees. So let's kind of draw that. Since it's a rhombus, um, basically all sides are the same. So this side, all these four sides are the same. And BAD is 60. So this is 60. So let's just cut this down right here. So then this is 60 also. The 60, because this has to be 120. That's just the idea of a rhombus. Okay. So CE is perpendicular. So we have CE to CB and CD. Okay. And BD is equal to 1, so this is 1, and BE is equal to BE is equal to 2. Okay, so let's draw that out. That's 2. Okay, and determine the length of AE. Okay, so let's actually put 2 right here. So then we could draw this length, right? So we need to find this length. So basically, to get this length, we have to draw this thing, right? So we need to get this length, and then we could do the Pythagorean theorem to get this length. So first, we know this is 1, since this is all equilateral, so that's 1, and this is 1. So if this is 1, this is a right triangle because that's perpendicular, then we need to get this length is just 1 squared plus the height squared is equal to the hypotenuse squared, which is 2 squared. So that's 4 minus 1, which is 3, and then h would be square root 3. Okay, so we got one of the lengths. Now we need to get this length. So if we cut this right here, we know this is length 1, right? So if this is length 1, then basically this length bisects it, so both of these are length 1/2. So what you need to understand about 30, 60, 90 triangles, right? This is 60, this is 30. It cuts it, so it makes out a perpendicular. So this is 1/2. The thing about 30, 60, 90 triangles is that if this is hypotenuse 1, then the opposite of this is half of that. And then opposite of the 60 is square root 3 over divided by 2 of this one, so square root 3 over 2. So if this is this just half the section is square root 3 over 2, that means the entire section is square root 3. So that is the length of that section. So I'll just redraw this part. So this triangle is just this triangle right here. So we have this is square root 3 and this is square root 3. So to get length x. Now use the Pythagorean theorem. So square root 3 squared, which is just 3, square root 3 squared is just 3, equals x squared. So that's 6 and then equals x squared. So x equals just square root 6. So that is your answer for number 7. Okay, number 8. A right equilateral triangle prism and so something like this. Okay, and a right circular cylinder. So we have a cylinder. Not the best artist. Have the same volume and the same height. So if they have the same height, then basically the base areas have to be the same. That's what they're telling us. Okay. So if the radius of the cylinder is 5, so this is a radius 5. So let's delete that first. So this is 5. Determine the length of each side of the equilateral triangle. Okay, equilateral. So we need to find x. So just the side length. So the area of this one is x squared, square root 3 over 4. That's that's always the formula to get the area of an equilateral triangle. Just memorize it because it's really useful. And that's equal to your area of the circle, which is pi radius squared. So pi times the radius, which is 5 squared. So now we need to just get x. So just use your calculator. So 5 squared is 25 times pi times 4 divided by square root 3 and then square root that to get our x. So x is equal to 13. So we had to get to 4 significant figures, so 13.47. And that is your answer for number 8. Number 9. AB is tangent to circle O at point B. The area of AOB is 24 and AB is 8. Determine the exact area of circle O. So since we know that the triangle is 24 square units, and one of the side length is 8. It's just 8 times the radius, because that's the point inside, divided by 2 is equal to your area, which is 24. So your radius is equal to 48 divided by 8 is 6. So to get the area of the radius is 6, so then our circle's area is pi radius squared, so that's just 6 squared times pi, which is 36 pi. And that is your answer for number 9. Basically just that simple. Okay, number 10. A 10-foot wide alley is level and has parallel vertical walls on each side. Okay. So we have some kind of alley, and it's 10 foot wide. Two adjacent poles lean against opposite sides, one on each wall with their bases against the foot of the other wall. Okay, so one pole reaches the vertical height of 30. So let's draw this one. So one pole, so from the foot on the other wall and to the height of the other one, that's height of 30. 30. And the other reaches 20. Okay, so this one here reaches 20. Not really drawn to scale. Okay, so determine the vertical height where the poles touch. So we need to find this height. So that's h. Okay, so let's just split these two side lengths and call this A and call this B. So what we have is using this triangle and this small triangle right here, right? That means it tells us that 30 divided by the A plus B is equal to H divided by A. Okay, so we know that's true. And now we know that 20, now we could just use this triangle and this smaller triangle, and we get 20 divided by A plus B is equal to H divided by B. Okay, and we also know that A plus B is equal to 10. So what we do is that we could divide these first two equations by each other. So then the A plus B cancel each other out, so it's just 30 divided by 20. And H over A divided by H over B is just going to be B over A. Okay, so that gives us that 30A is equal to 20B. So A is equal to 2/3 of B. Okay, so we know A is 2/3 of B, so just substitute that in. So now we just solve this one using proportions again. So we know 30 over the entire length, which is 2 over 3B plus B. So that's 3 over 3 plus 2 over 3, which is 5 over 3B, is equal to H divided by 2 over 3B. So we could cancel out the B's, so we don't need that anymore. And then we just multiply this 2/3 to that side, and we could get our H. So 30 divided by 5 over 3 times 2/3. And we get our height is equal to 12. And that is our answer for number 10. Okay, number 11. Let let P, Q, R, and T be coplanar points such that Q lies on TR and triangle PQR, TPQ, and TRP are similar. Okay, that's an interesting property. If TR is equal to 17 square root 3 and PQ equals 51 over 4, determine the sum of the two possible lengths of TP and in this form and then add the coefficients basically. Okay, so the reason I said it was such an interesting property with these triangles is that if you're given 4 points and they all work together, um, and it also says the Q lies on TR, how it kind of looks like, okay, let's just give an example. So we have TR, so let's say that's T and that's R, and Q lies on it. Let's say this is Q. Okay, and we have our point P. What it basically tells us, since all these triangles are the same, there's actually a really, really special triangle that kind of works like this. It's actually, I'm not exactly sure what the name is, but basically I call it a right and right triangle. So how it kind of works is we have a right triangle and right, a right triangle here, and then you put a right triangle here, right? Then if we draw an altitude, which is what we've been doing for a bunch of these questions, it tells us that this triangle and this triangle and this overall triangle, all these three triangles are the same. And that's not same, similar. So when they said for number 11 for the first sentence that three of these triangles are similar, what it's kind of implying is that they're using a right and a right triangle. So basically, I'm just going to do that. Okay. So we have this section. So I'll draw like this. Then we have another right triangle. Okay. So we're not gonna compare angles the entire time because it's gonna take way too long. Okay, number 11. So we have Q lies on TR, so let's just call this T and let's call this R. and this one's Q. This one's P. Okay, so TR is 17 square root 3, so this entire length is 17 square root 3. And PQ, so this length is 51 over 4. Determine then the sum of the two possible lengths of TP. So we need to find this length, so this is X. Um, so there's two possible lengths though, right? So why is that? Well, imagine if your T and R, right? It says it lies on TR. So we don't know where TR is. So we could just call this R and call this one T, and now your X is right here instead of here, right? So basically, what they want us to do is that they want us to find both these lengths, so x and y. So they want us to find the length of the legs. So that's all we need to look for. So what we could do is that we could just set up a bunch of equations. So we know, since this is our hypotenuse 17 squared 3, then we just use the Pythagorean theorem. So x squared plus y squared is equal to 17 square root 3 squared. Okay, and we also know that since this is the altitude, which is 51 over 4, then we know that the area, which is x times y, divided by 2, is equal to the area of this portion, which is 17 square root 3 times 51 over 4 times 1 half. Well, we've been doing so for like some other questions too, right? So we could just cancel out those 1 halves because we actually don't need it. So we have x times y equals 51 over 4 times 17 square root 3. Okay, so what we're looking for is that we're looking for x plus y, right? So we're looking for this. So we actually don't need to solve for x and y, what x is and what y is. We just need to solve for x plus y. So if we look at our first equation, what we would do is that we could rewrite it and say it's x plus y squared. What does that come out to? That's x squared plus 2xy plus y squared, right? That's x squared and y squared, which is right here. And we have an extra x squared plus y squared. So we need to take that out. So from this equation, we could just minus a 2xy is equal to, right? So it's just so this entire thing is just equal to each other. So it's equal to this. So 17 squared times square root 3 squared is just 3. So that gives us that x plus y is equal to the square root of 17 squared times 3, and then move two, the 2xy to the other side and then take the square root, right? So plus 2 times x times y, we already got it right here, right? So, which is 51 over 4 times 17 squared 3. So I'm just going to cancel out the 2's. So the 4 turns to a 2 times 17 squared 3. And that gets our x and y. Okay, so we don't need that anymore. We just need to solve this equation. I mean, we just need to simplify this. So that gives us that x plus y is equal to 51 is 17 times 3. So we could just factor out a 17 squared. So we have a 17, so 17 squared, square root of that is just 17. So we have a 3 plus a 3 over 2 square root 3. Okay, so we need to simplify this portion, right, to make it look like k plus w squared p over f. So what we could do is I could write a plus square root b squared and then take the square root, and we could set this square root equal to this square root. So when so then it kind of matches out because when this factors out, this is a squared plus 2a square root b plus square root b squared is b, right? So this is what it factors out to. So the constants are a squared plus b. So a squared plus b is equal to our 3. And then 2a squared, 2a times square b, we could put this all in the radical. So that's 4a squared b is equal to, put all this in the radical. So this is 9 over 4 times 3, which is 27 over 4. Okay. And now we just need to solve for this system. So we could just plug in a squared. So then this is 4. So this a squared is equal to 3 minus b. 4, right? So now let's delete all this because we don't need it. And we just need to solve for this section. So this is like a quadratic, so move 4 to the other side, so then this is just negative b squared. So move that also to the other side, so that's b squared. This is plus 3b, so this is minus 3b. And then on this side, it would be plus 27 over 16 equals 0, right? So what we'll do is use the quadratic formula, so negative b plus b squared, which is 9 minus 4ac. So minus 4, so cancel out with the 16, which is just 27 over your 4, all over 2a. Okay, so 9 is 36 over 4. So that's 9 over 4. So square root 9 over 4 is 3 over 2. So this is 3 plus 3 over 2 over 2. So this is 6 over 2. 6 over 2 plus 3 over 2 is 9 over 2. Divided by 2 is uh, 9 over 4. So that is what our b is. So b equals 9 over 4. Okay. So remember, I kind of deleted it, but basically a squared plus b has to be equal to our 3, right? So then 3 minus 9 over 4. So 3 is 12 over 4 minus 9 over 4 equals 3 over 4, right? So then we have 3 over 4. So a is equal to square root 3 over 4, which is just square root 3 over 2. So that is equal to our a. Okay, so we got our a and b. Now, the reason we did all that basically is because if we square something and then we take the square root, those cancel each other out. Okay, so that means all you're left with is a plus square root b, which is what we said is equal to this. So then a is square root 3 over 2, b, and then square root b, so we have to take the square root of 9 over 4. So square root of 9 is 3, square root of 4 is 2. So then square root 3 plus 2, 3 over 2 square root 3 is equal to just square root 3 over 2 plus 3 over 2. And then we're going to multiply that by 17. And that will give us our x plus y. Okay, so it's just a bunch of simplifying. So we have 17 square root 3 plus 17 times 3 is 51. And then they're all over 2 because it's already a common denominator. So then our k is 51, our w is 17, our p is 3, and our f is 2. So I add that together, 3 plus 2 is 5, plus this is 22, plus this is 73. So that is your answer for number 11. Number 12. Uh, Let A, B, C, D, E, F be equally spaced around a circle. Okay, so GF is tangent to the circle at F. Determine the degree measure of angle GFA. So we have a line and we have also a circle. Not the best artist. So we have equally spaced. So 1, 2, 3, 4, 5, and 6. So since I counted there was 6, right? There's 6 points. Then basically this is gonna be a hexagon because they're equally spaced. So it's gonna be a regular hexagon. So a hexagon is 120 degrees. So all these are 120 degrees. So we need to find GFA. So we need to find this angle right here. So this angle is, if we think about this entire thing as 180 degrees, right? If this portion is 120, then if you think logically, this angle should be equal to this angle. So let's just call this x. So add 2x is equal to 180. So 60 is equal to 2x, so x is equal to 30. And that is your answer. So your answer for number 12 is 30. Okay. Number 13. A a right circular cylinder with lower base circle of radius 4 is truncated at an angle to the vertical axis so that the top base is an ellipse. Okay, so basically we had a cylinder, and then it's cut at an angle, so it's cut like this. So then now we have like an ellipse, and then we have our cylinder. Okay, so it has a radius of 4, which is what they gave us. And they said the longest height is 9, so this is the longest, and the shortest is 7. So determine the exact volume of this truncated cylinder. So we need to find the volume of this. So what you could think about it is, what happened if this is a full cylinder, right? So we cut it right here. So if we cut it right here, this and this, I mean, the area for this is not the same. But imagine we have a I mean, the volume of this one is not necessarily the same. But imagine we have another like thing like this, and this one was 9, and this one was 7, and this is also radius 4, right? If you connect them together, sorry, I can't speak. Connect them together, we have a full cylinder, and we have a 9 plus the 7 equals 16, right? 9 plus 7 is 16, and radius 4, right? So since these two are the exact same, we could just divide by 2. So we just need to find this volume of this and then divide by 2. So then we do pi radius squared. So times your height, which is 16, divided by 2. So then we get an area, a volume of 4 times 4 times 16 divided by 2 is 128 pi. And that's your answer for number 13. Number 14. Triangle ABC is inscribed in a circle. So we have a circle and we have triangle ABC. If AB is 16, BC is 30, and AC is 34, so that's just side length of triangles. So that's 16, 30, 34. A point is chosen at random from the inside of a circle, so the inside of the circle. Determine the probability that's also in the triangle. Okay, so basically, we need to find the area of the triangle over the area of the circle, right? Because that's the probability that's hit in the triangle and the circle over the entire circle. So the area of the triangle, what you could what you could do is that since I see that 16, 34, and 30 are all evens, we just divide by 2. So that would be 8, that would be 15, and that would be 17. 8, 15, and 17 is a Pythagorean triple. So what it basically tells us is 8 squared plus 15 squared equals 17 squared. That's true. You could use your calculator and check it, but it's actually true. So what this tells us is basically that this is a right triangle. So the right is right here. It doesn't look like it because I didn't draw as a right triangle at the beginning. So that means the area of the triangle is 16 times 30 divided by 2. So that's the area of this triangle. So what's the area of the circle? Well, first we need to find the radius. So for triangles, if it's a right triangle, try and make best to draw. Okay, if it's a right triangle, the hypotenuse always goes through the center of the circle. And the hypotenuse is always 2 times the length, because this length is equal to this length. So the radius is always just half the hypotenuse. So basically, since our hypotenuse is 34, that means our radius is 17. So our radius is 17, so pi radius squared. So 17 squared, and then put a pi. So using our calculator to find it, so we have 16 times 30 divided by 2 divided by 17 squared, and then divided by pi, and we should get a probability to four significant figures 0.2643. And that is your answer for number 14. Okay. 15. Given the diagram with angle measures as shown, determine the degree measure of obtuse angle DBA. DBC. Okay, so basically, just kind of draw a picture. So we need to find this one right here. So this one's x squared. This one's 25 minus x. This one's 3x plus 55. So the angles not touching is equal to exterior, right? Which is what I said before. So 3x plus minus x equals 2x. 55 plus 25 is 80, is equal to your x squared. So that means x squared minus 2x minus 80 is equal to 0. So this is 8 and 10. So minus 10, x plus 8. So x equals 10 or x equals negative 8. So since I know that this angle is supposed to be a acute angle, right? Because it's less than 90. It cannot be 10 because it's got to be 10 squared is 100. That's obtuse, so it's not this one. So it's got to be negative 8. So negative 8 squared is 64. So since we're trying to look for this angle, it's just 180 minus that 64, which is equal to 116. So that is your answer for number 15. Okay, number 16. In the in the rectangular solid shown, not drawn to scale, CG is 8. Okay, so let's kind of draw this. It's fine. CG is 8, so this is 8. GH is 12, and CB is 9. Okay, determine the exact length of BH, so from here to here. Okay, so for space diagonals, which is what these are referred to, or one of the names basically, is you just take all those side lengths, square them, and then add them together and then square root it, and that should be the diagonal length. So it's just 9 squared plus 8 squared plus 12 squared. Square root is your length. So using your calculator, 9 squared plus 8 squared plus 12 squared, square root it, and you get a length of 17. So that is your answer for number 16. It's basically just that simple. Number 17. A regular hexagon with sides of length 8 has both a circumscribed circle and a inscribed circle. Okay, so a circumscribed circle is outside, so let's draw our hexagon. So 1, 2, 3, 4, 5, 6. And it's regular, so all the side lengths are the same. Okay, so that's your circumscribed circle, and it's an inscribed circle. So inscribed circle basically touches all the side lengths, like so something like this. I'm not the best artist, but basically what it is. And then we have a center circle. So determine the ratio of the area of the inscribed to the circumscribed. Okay, so if this is area 8, right? I mean side length 8. So what you notice is if we kind of draw our triangle here, basically this is side length 8, 8, and 8. Because if this is a hexagon, it's just made by 6 equilateral triangles. That's what a hexagon is. A regular hexagon is. So that means our radius is 8 for our circumscribed, because that's the circle outside. So we have to inscribe over circumscribed, so it's on the bottom. So pi radius squared, so pi 8 squared. Okay, so now we need to find the radius of inscribed. So it touches the side length, so it's right here. So let's connect our triangles. So basically we know this is 8, as I said before. So I'll draw this again on the bottom because we have too much stuff going on right now. So since it's touching right here, it's 90 degrees, and this is 8 and 8. So we know that a that the degree measure of a like a corner basically of a hexagon is 120 degrees, right? So this is 120. So since you could draw another triangle right here, and since both of these angles have to be the same, then basically 120 divided by 2 is 60. So that gives us this is 60. And that's why it makes sense because this is already equilateral, right? So opposite of 60, as I said before for 3069 triangle, is square root 3 over 2 of that side length. So 8 times square root 3 over 2 is equal to 4 square root 3. And that's this length, which is this. So that is your circumradius. I mean your inradius, basically. So that's pi radius squared. Cancel your pi's because you won't need it. 4 times 4 is 16, and this is 3. And then we have an 8 squared, which is 8 times 8. So cancel out, that's 2. Cancel out this 2 with this one is 4. So the ratio, which k to w is 3 to 4. So that is your answer for number 17. I suggest you actually learn inscribed circle and circumscribed circles. They use it a bunch in math competitions. Okay, two congruent squares with the same center are positioned so that the diagonals of one of the squares is rotated 45 degrees from the other, producing shaded triangles with equal areas. The numerical area of one of these triangles is 2 square root 2 minus 2. Determine the exact numerical area of the octagonal region that remains unshaded inside the squares. Okay, so looking at that diagram, basically all 8 of those, 2, 4, 6, 8, yeah, all 8 of those areas have the same because that's what they said, which makes sense, right? So if you kind of logically think about it, that means the octagon that's made from it has to be regular. So that basically means all the side lengths of the octagon has to be the same length. And because since all the area is the same, then generally all the side lengths of it has to be the same because it's created the same way if you kind of logically think about it. So using that mentality, right? Then basically we could just calculate the side length of the diagonal. So we could just have this. And we know this area is 2 square root 2 minus 2. So we know this is a basically a 45, 45, 90, right? Because these two side lengths has to be the same. So opposite of a 45, 45, 90 is x squared root 2. That's the side length. So, and this is also the side length of our octagonal, uh, the side length of our octagonal region, basically. So we just need to find what x is. So we know x squared, x times x divided by 2, is area is equal to 2 square root 2 minus 2. So that means that gives us that our x squared is equal to 4, oops, x squared is equal to 4 square root 2 minus 4. Okay, so that means our x is equal to square root 4 square root 2 minus 4. Okay, so we got that section. So that means if we want to get our x squared 2, we just need to multiply this by square root 2. So since they both have square root, we just need to multiply the 2 by inside. So that's 8 square root 2 minus 8. Okay, so that is our side length for our octagonal region. So the formula to get an area of a octagon is 2, 1 plus square root 2 x squared, where x is the side length. So we already have x, right? This is our x. Well, I'm using two different x's. X is for the side length of the triangle, and also I'm using. Okay, let's just redefine it because I might be confusing. Let's just call this a. So that a is the side length of our octagon. So let's call that a squared. Okay, so we have 2, 1 plus square root 2, and then a squared. So square root of this is just 8 square root 2 minus 8. So let's multiply them together. Let's just distribute out the 8. So it's just 2 times 8. And then we have 1 plus square root 2. And when you divide that by 8, that's just square root 2 minus 1. Right? So square root 2 times square root 2 is 2. Square root 2 times this negative 1. Square root 2 times this 1. Those cancel each other out. And then negative 1 times this, so 1 is minus 1. So 2 minus 1 is 1. So this entire thing just multiplies out to 1. Okay? So then 2 times 8 times 1 is just 16. And that is your answer for number 18. Basically, just that simple. You just know your formulas, so you should be fine. Okay, number 19. PQR, median QT, and median PS are congruent at point C. Okay, so I'm gonna draw one more side length right here. So the reason I did this is that all these points are always gonna, three medians are always gonna coincide in one point in a triangle, and that point is called the centroid. So let's just label everything else first. So PC is 4x minus 6, and CS is x. So the interesting property about centroids is basically the length from the vertex to the centroid to the side length is a 2-to-1 ratio. So this is a 2-to-1 ratio, this is a 2-to-1 ratio, and this is a 2-to-1 ratio. So that basically tells us that 4x minus 6 divided by x is equal to 2-to-1 ratio. So that's cross multiply. So 2x is equal to 6, so x is equal to 3. So to find the length of PS, so this entire length, which is 5x minus 6, plug in your 3 in here. So that's 15 minus 6 equal to 9. So that's your answer for number 19. Okay, final answer, 20. Determine the exact numerical length of the altitude to the hypotenuse of a right triangle with lengths 8 and square root 3. Okay, so you have a right triangle, legs 8, and the other one 8 square root 3. So we need to find the length of the altitude. Okay, so if you ever see a square root 3, it's actually kind of, it basically tells you that you're using a 30, 60, 90 triangle. So opposite of the square root 3 is the 60, and opposite of the 30 is the other one. So basically, it tells us that if the 30 is half the hypotenuse, so 8 is here, so that means this one's 16. Okay, so to get our altitude, which is h, all we have to do is just use what we've been doing so far. 8 square root 3 times 8 divided by 2 equals 16 times h divided by 2. Cancel out the 2's because we don't need it. So now we find out that 16, so that cancel out the 8 and then cancel out this 8 to make a 4. So our height is 4 square root 3. And that's your answer for 20. Okay. And we conclude it with an easy question. So overall, you should just know your 30, 60, 90 triangle, which is basically 30, 60, right? 90 is the right angle. So this is side length x. Opposite of the 30 is x divided by 2, and opposite of the 60 is x squared root 3 over 2. And then the area would get you for this is x squared square root 3 divided by uh, divide by 4, and then multiply divide by 4 times and then divide by 2. So okay, so this would be your area, and that's why right, square root 3 over 8, and that's why a um a 60 like equilateral triangle, so 30, 60, right? So 30 plus 30, 60. So this is the equilateral triangle, and that's why an equilateral triangle is formula is x squared square root 3 over 4, because there's two of them, so we multiply by 2. So that's an interesting thing you should know, because it's gonna help out with your calculations super fast. Um, Overall, no congruency, concurrent, right? So there's some special properties that you need to know. Some basic formulas like finding the length of a space diagonal. No inscribed angles and inscribed and circumscribed radiuses. It used the same thing here. Some general more formulas. And some questions like number 11, you might, if you don't know the property, you might want to skip because it might take a while. And other things, you just need to draw pictures. I recommend for geometry, just draw pictures all the time. And then questions like 5, you might just want to skip over on and do it later, like at the very end, because it's just way too much information and there's too much calculations to work with later on. Unless you know it, then it should be then it might be fast, but it's if taking the risk is kind of sometimes questionable. So you just like score points on the other questions rather than the ones that are really long. And basic formulas like perimeter, working with common external tangents and some basic angles. And then know your inscribed angles and lines, basically. Well, thanks for watching, and I'll see you at the next math record.